Hey guys, this video is for page 37 of your interactive notebook on predicting products of replacement reactions. The purpose of this is to be able to write an entire chemical equation for a single or double replacement reaction after having only been given the reactants. So we're going to break this apart into two different sections, one on single replacement, which we'll do first, and then one on double replacement reactions, which we'll do second. For single replacement reactions, in order to determine the products, we must first determine whether or not a reaction will actually occur. In order for a reaction to occur, the metal or the nonmetal that will replace the cation, or the anion if it's a nonmetal, in a compound must be more active than the other substance. We use an activity series to determine which one is more active, and then remember that more active metals will always replace less active metals. The activity series can be found on your reference materials for class. So the activity series is right here, and this arrow points in the direction of increasing activity. So in other words, lithium is more active than barium. Manganese is less active than sodium. That's how we use this. So let's look at a couple of examples here on the left. The first one is magnesium plus HCl, Mg plus HCl. This produces magnesium chloride and hydrogen. But in order to determine that, we have to use the activity series to see whether or not magnesium will actually replace hydrogen. So when we refer to the activity series, we find that magnesium is here, and hydrogen is all the way down here, meaning that magnesium is much more active. So since magnesium is more active, it will replace hydrogen in this compound. The second example is zinc plus copper 2 chloride. These react to form zinc chloride and copper because zinc is a more active metal than copper. In the case of copper plus aluminum chloride, no reaction will actually occur because aluminum is more active than copper. And since copper is less active, it can't actually replace aluminum in this compound. Lastly, we have iron plus copper 2 nitrate. Iron is more reactive than copper, so it will displace copper in the compound, forming iron 2 nitrate and copper. All right, let's talk about double replacement reactions now. In a double replacement reaction, at least one of the products will have to be a pure liquid, gas, or a solid precipitate. Otherwise, no real reaction occurs. Remember that these reactions are occurring between aqueous substances, or at least one of the substances will be aqueous and the other one will usually be soluble. So when you combine them, they both become aqueous. And if the product that they make is not a pure liquid, solid, or gas, well then it's just also going to remain in solution, and you're not going to observe any noticeable change. You're not going to really form a new product. So we're always looking for the formation of a gas, liquid, or solid. Common gases that will be produced are going to include O2, H2, Cl2, F2, and CO2. There certainly are a lot of other possibilities. Often if a liquid is formed, it's going to either be water or ammonia. And again, there's lots of other possibilities, but these are the two that we'll usually see. And finally, if it's not a liquid or a solid, it might produce a precipitate. I mean, if it's not a liquid or a gas, it might produce a solid precipitate. And so we're going to have to check the solubility of all of our products to determine whether or not they'll precipitate. And to determine the solubility, we can refer to a solubility chart. If both of our products are soluble, then no precipitate forms and there's no chemical reaction, assuming that a liquid or a gas didn't form either. So we'll look at some examples here on the left. We're going to start with silver 1 nitrate reacting with potassium chromate. This will produce potassium nitrate, which is soluble, it's aqueous, and silver 1 chromate, which is not soluble, so it's a precipitate, it's a solid. You'll notice neither of these are gases or liquids that we discussed, so we're going to move straight into determining whether or not they precipitate. Again, you're going to use your reference materials for this. You'll find a chart of solubility of common ionic compounds. So for this case, we have potassium nitrate. This chart is based on the anion. So you're going to scan for the anion, which is nitrate, NO3-. It says that nitrates are soluble with no exceptions. So that's how we knew to call this aqueous. The other one is silver 1 chromate. So chromates are anion. We're going to scan this list of soluble compounds for chromate, and we don't find any chromate ions here, which means it's probably insoluble. So we go to the bottom where it lists insoluble compounds, and sure enough, here's chromate. So compounds that contain chromate are generally insoluble. There are some exceptions, like compounds that include ammonium as the cation or alkali metal cations, but that's not the case here. Our cation is silver, which is neither of those. So this compound is insoluble, which means that it's a solid. Our next equation is between sodium sulfate and barium chloride. It produces barium sulfate, which we'll learn from our reference materials is insoluble, so it's a solid, and sodium chloride, which is soluble, so it's aqueous. Then we have lithium hydroxide plus sodium chromate. This should form lithium chromate and sodium hydroxide, but both of those products are soluble according to our solubility chart. So we're going to say that in fact no reaction occurs. The last example is a bit of an odd case. We have ammonium chloride reacting with sodium hydroxide, which should form sodium chloride, which is soluble, and sodium hydroxide, which is soluble. So what you should be saying to yourself right now is no reaction occurs. It forms two aqueous products, so nothing's going to really change. However, this is a different case from any of the others that we're going to look at, in that ammonium hydroxide forms ammonia and water, both of which are liquids. So rather than staying in an aqueous solution, sodium hydroxide or ammonium hydroxide will actually decompose to form those two products. So our real chemical equation is ammonium chloride plus sodium hydroxide produces sodium chloride, ammonia, and water. And because these are pure liquids, this is a chemical reaction. You can get some more practice on the Predicting Products of Replacement Reactions practice worksheet, then glue that into the left side of page 37, and that's it for Predicting Products of Replacement Reactions.